Hi guys, in this video you will learn about the first shifting theory of Laplace transform. All the examples in this video will be based on Laplace transform table, okay? So all the examples when you are being given a, a function in the time domain or a function in the spatial domain, you will just have to refer back to this basic table of Laplace transform. Alright, now so basically, the first shifting theory of Laplace transform says that, before I go into the first shifting theory, let's start with the basic Laplace transform itself. Okay, Laplace transform basically transform a function in time domain into a function in spatial domain. But if this function in time domain is being multiplied with a kernel, such as the kernel is exponential to the power of at, so the function in the spatial domain will be shifted by s minus a. Alright, so this is what it means by the first shifting theory of Laplace transform. Alright, in other words, if the function in the time domain is multiplied with a kernel of exponential to the power of at, the function in the spatial domain will be shifted by s minus a. So this is the theory of the first shifting theory of Laplace transform. Alright, now let's start with an example. Assuming you are being given a function gt which is equivalent to exponential to the power of at multiplied with cos omega t. Alright, now the question asks you what is gs. Okay, now how do you do this? Okay, first thing first, you realize that this is the function itself. If you take this cos omega t as a separate function ft, and you refer this to the Laplace transform table, this will becomes, when we have ft equivalent to cos omega t, you will get a function in the spatial domain which is s over s squared plus omega squared. Alright, so this is the pair that you will see in the basic table of Laplace transform. Alright, now you realize this, your gt here is ft multiplied with a kernel function which is exponential to the power of at. Therefore, your gs here will have to be using the first shifting theory of Laplace transform, which is shifted by s minus a. Alright, so here your answer will be s minus a over s minus a square plus omega square. Now, if you're wondering how I derive this, if we look here, if this is s in a fs domain, so this becomes s minus a in the fs minus a domain. And if this is s square in the fs domain, so in fs minus a domain, shifted domain, you will get s minus a square. Alright, so this is how we get the answer of our first example. Now guys, let's go to the next example. Assuming you are being given a function in the time domain which is gt is equivalent to exponential to the power of at multiplied with t squared. Now, if we look here, we can try to separate t square as another function ft. So from here, if t square, if ft is equivalent to t square, you can refer to the table of basic Laplace transform. You will get fs, which is equivalent to 2 factorial over s cubed. All right, this is from our table. Okay, so in this case, all right, your gs will then have to be a function of s which is shifted by s minus a. Okay, so here you will get an answer of 2 factorial over s minus a to the power of 3. Right, how do I derive this? Now, if you're wondering how I derive this, if this is s cubed in fs domain, so in a shifted fs minus a domain, you will get s minus a cubed. It's as simple as that. All right. Okay. So now I have given you basically 2 examples on how you do first shifting theory in Laplace transform. Let's try to do the inverse Laplace transform by using first shifting theory. Okay, now let's start with the basic formula again. If we have Laplace of ft is equivalent to fs, and by using first shifting theory, you have like Laplace of ft, which is multiplied with another kernel e to the power of at, and here you will get f, which is shifted by s minus a. The inverse of f s minus a is equivalent to ft multiply with the kernel function again, exponential to the power of at. It's as simple as that. Now let me give you an example for this. Yeah, assuming you are being given a function which is fs is equivalent to 3s minus with 137 over s square plus 2s plus 401. And the question said, what is the ft? Okay, now, in order to derive this, you realize that this function is actually in polynomial form. All right, so you can, in order to get 2s here, we must have like s plus 1, s plus 1, so you will get s squared plus 2s plus 1. All right, so let's go back to our question. So here, your fs is actually 3s minus with 137 over s plus 1 square. So if we have 1 here, already here, the remaining here will be 400. All right, and let's try to convert that into familiar form. So we are familiar with 100. Hold on, I'll write this first. Over s plus 1 square. We are familiar with the form of 20 square because you know that when fs is s over s square plus omega square, the pair of it, ft, is actually cos omega t. So this is one pair. And the other pair, when you have fs is equivalent omega over s square plus omega square, your ft is actually sine omega t. Alright, this is another pair. Okay, now coming back to our question here. So since this is s plus 1, you need to put the top one also in the form of s plus 1. So here I will put 3s plus 1. So we have here 3s, which is 3s plus 3. So when you have plus 3 here, this will become minus 140 instead. Alright, so this will be s plus 1 square plus 20 square. So now we can convert it into two separate components. The first component is equivalent to 3s plus 1 over s plus 1 square plus 20 square. The second component is, this should be negative 140 over s plus 1 square plus with 20 square. So now ft here, clearly because this is 3, so it will be 3. This is in familiar form, s over s square plus omega square. So this is cos, the omega is 20, so cos 20 t. And this is the first shifting theory multiplied with exponential. And here a is actually negative 1, so minus t. So this is for the first component. The second one, 140 here, is actually minus 7. Alright, so when you minus 7, this becomes 20 on top here. So this will be again first shifting theory, e to the power of minus t multiplied with sine 20t. Now if you realize how I derived this, alright, let's just put here this minus 140 as 7 and multiply with 20. Alright, so the 3 comes here, the 7 comes here. Alright, the omega is 20, which is here, 20, which is here. Okay, and this implies the first shifting theory, which is here. Again, this is first shifting theory, which is here. Alright, so I hope this is clear enough, the example of the first shifting theory. So you are being given two examples here of first shifting theory when you do Laplace transform, and this is an example of first shifting theory by using inverse Laplace transform. That's it for today and for this video. Thank you guys. All the best.